is called the limit comparison test, and it looks a lot uglier than it is. So I'm going to talk through it a little bit, and then we'll also do a couple of different examples of it. So you're going to have two series. Notice that your terms are positive, so that should be familiar. And then what I want you to do is think, oh, B sub n is going to be a series I know about. I know whether it converges or diverges. And A sub n is going to be a series I have questions. Excuse me. A sub n is going to be a series I have questions about. So what you do is you say, okay, I've got a series I know about. I've got another series that I'm questioning. You make a ratio out of those two series, the nth term of those two series. You take the limit as n goes to infinity. And if you get a number between 0 and infinity, then whatever B sub n does, so does A sub n. Okay, so if B sub n converges, so does A sub n. If B sub n diverges, then so does A sub n. Okay. If you get 0, if the series that you know about converges, then so does the one that you're interested in. And if you get infinity, and the series you know something about diverges, then so does the one you're interested in. So that's a quick summary. You might want to take a minute and summarize it for yourself in your notes, but here's the key. This is the part that I want you to take home from the limit comparison test. You're going to compare the series to its end behavior. So you're going to have a big, ugly, complicated series, and you're going to compare it to its end behavior. That's going to be the key to the limit comparison test. All right, take a minute and summarize the limit comparison test, and then come back and we'll do a couple of examples. All right, so here's an example I'm looking at. It's ugly and complicated, but I remember that I heard that the key was to think end behavior. So the series that I'm going to compare this to, so I'm going to say let B sub n is equal to n equals 1 to infinity of 2n over n squared, which is the same thing as 2 over n, which is the same thing as 2 times 1 over n, which diverges by the p-series test. Because the exponent here is a 1, and the p-series test says that will diverge if that exponent is less than or equal to 1. This series is also a very famous series. It's called the harmonic series. It's 1 plus 1/2 plus 1/3 plus 1/4. And this one is one that you should for sure know diverges. It comes up a lot, and it's just really handy to immediately see that and say, oh, that diverges. It's a p-series, so it follows that rule, but it's really handy to know that that one diverges. You can prove it with the integral test. Okay, so B sub n diverges. And so then what we're going to do is we're going to make a ratio. So we're going to do the limit as n goes to infinity. And we're going to start at 1. And we'll do A sub n over B sub n. You can either use 2 over n or you can use 1 over n. It doesn't matter. Either one will work. So I'm just going to be consistent and use 2 over n. So then this will be the same thing as, now I'm going to do a bunch of simplifying, and I'm still kind of thinking n behavior because it is a limit as n goes to infinity. And I should not have done this as a sum. Sorry, I'm just doing the limit of the nth term. Okay. So then I have 2n plus 1 over n plus 1 squared times n over 2. And then, again, this is limit as n goes to infinity, so I really get to use end behavior again. So it's going to be n goes to infinity of 2n squared over, 2n squared, which is 1. 1 makes us happy when we're doing this because we have a divergent series. We took the limit, and so therefore we got a number that was between 0 and infinity. So therefore, our series also diverges. They converge or diverge together. So the one I'm comparing it to diverges. I got a 1 for a limit, so does the one that I'm looking at. Okay? So that's what I mean by using end behavior. You use it kind of twice. You use it when you find a series that you can compare it to, and you use it when you're taking that limit as n goes to infinity. All right, so try this example. Try to come up with a series that you can compare it to, and then after you've found a series, then you can use the limit comparison test to see if this one converges or diverges. Okay, so step 1, I'm going to compare to (3n over n cubed), which is the same thing as 3 times 1 over n squared, which converges by the p-series test, because now the exponent is 2, so that means it converges. And then I'm going to do the limit as n goes to infinity of this series that I'm looking at, divided by 1 over n squared, or I could do 3 over n squared, it doesn't matter. And then I simplify as much as I can. And remember, you get to use end behavior, so you have 3n plus 2 divided by n cubed minus 2n times n squared. So the end behavior is 3n cubed over n cubed. So that's 3. So since I got a number between 0 and infinity, this series converges by limit comparison. Okay, so those are 3 big new tests in this unit. Your first test is integral test. Your second test is the p-series test, and then this third test is the limit comparison test. And please think end behavior when you're thinking the limit comparison test, as you're trying to find a series which you can compare it to. Okay, that's a summary of this lesson. Good luck.